This meeting is being recorded.
Welcome to today's video about system design for data professionals. I am Mary Lobel. I'm a former staff data engineer at Meta. I have a ton of experience in data science and data engineering. In the past, I have successfully scaled up and productized machine learning solutions. I have a background in NLP development, and I have also had some successes with growing some local communities. I have a PhD in medical image computing from Belgium. Let's check out today's breakdown of my presentation. I will be discussing a real-world application of system design. I will be building out a data-driven social media content engine. It's important to note also here that this will be built out from scratch. So we will not be discussing like an established system like LinkedIn, Instagram, or Facebook, but we're just thinking which choices would we make today when we're building out a new system. To understand how we can build out a data-driven approach, we first need to research the data points that are available from us. Once we have the data points, we can start building out the engine. Such an engine will always consist of two parts, an analytics reporting part and a machine learning part. Once we have built out this engine, we can see how we can actually refine this engine further and how we can actually also use this to recommend user actions so that we really can have the power of machine learning in action. Finally, we will conclude this presentation with a conclusion and call to action. But let us first start with the introduction. A practical problem of content marketing is currently that we know that a lot of content can be effectively generated with generative AI, but we mainly worry that this content is not going to be really genuine. But on the other side, we also just know if we need to build a lot of original content, it just takes a lot of time. Therefore, it's important to just find the correct balance and just know how we can actually build a healthy content funnel. How will we actually be able to see whether we have a healthy content funnel? Let's therefore check out some of the graphs that we actually have available from LinkedIn. What you see here is the content performance graphs that LinkedIn is providing to us. You see here the total amount of impressions that we have over the last 90 days, and we can see for each day the amount of impressions that our account has gathered. We see that we have peaks and valleys in our content performance graph. But it's then important to know when we are at a certain point, should we create new content, should we boost content, or just should we leave for now our content engine? How can we see this, that this is actually a challenge? If you now check here on the right, I have provided an overview of some of the posts that I have published over the last 7 days. Here it's clearly to see that not all of these posts are getting the same amount of views, and that you also need to be careful if you will keep pushing both posts that people actually might get bored of you, and in that way you actually might be damaging the amount of followers that you have. So therefore, it's really important to find the balance in creating new content, pushing more articles, so that at the end of the day, we can get to a healthy funnel. So let us now check further who is all involved in building such a great data application. A data application is in these recent days not built alone anymore. We have a lot of people involved from the technical, business, customer side, user experience side, and responsible AI side. We probably are most familiar with data engineering, data scientists, machine learning engineers, and software developers, but we probably also have worked in the past with product managers, customer success, UX researchers, and we also all care now about building our apps responsible. So therefore, we also work closely with legal compliance, security, and privacy. My call to action now is that you will check in the following slides where you would be finding all these rolls back in the designs that we're sharing. So the main goal of today's presentation is just to demystify further the building of such a modern data application app. And by going through the whole presentation, you will also understand how this is actually relevant for you in interview preparation. So we have already discussed that we actually will use a relevant application that is on top of mind for a lot of people. We will show that we need to have such a system designed so that we effectively can work in a team together. And some of the real world applications that we will discuss or answer here is, when do I write a new blog? When do I just boost a blog? Or when should I take a break on posting so that I'm not going to harm my follower account? So basically how it would look like, here at the left, you see that we currently have a bit of a dip in our content performance. And now we should wonder, should we just boost a few of our top posts or just hope that they still will be taking on further? Or should we actually maybe boost some of our lower posts who might be promising, but for just some reason didn't make it through a lot of distribution? These are just all of the questions that we actually can answer. So now that we clearly understand the problem that we want to solve, let's go to the data-driven approach. To build out a data-driven content engine, the most important thing that you need to have is data. Like we discussed earlier, we want to use the data that is available from LinkedIn. But we first also need to understand how we can actually extract these data to our database. So here I have provided an overview of the different types of data points that are available for us. It's also important to see that these data points are available for different time windows, for 90 days, 28 days, 14 days, and 7 days. And if you would check out LinkedIn, you will also see that they are also available for 365 days. Some of this data is on account level, and other of that data is on post level. For the account level data, we have the content performance graphs. These show for each day how many impressions our account has gotten. It's also important to note here that these graphs are only available through the UI and that we can't directly download these graphs through the LinkedIn API. Next, we have the impressions versus viewers number. What does this actually mean? When you have impressions that are showing how many times your post has been shown, it actually might be that your post is multiple times shown to the same users. To really understand how many unique views your posts are getting, you need to have the unique views, and in this way you know how many different accounts your content has reached. This is again information that is not available through the APIs, but we can actually make some screenshots from this, and in this way we can actually easily extract this data. Next, we have post level information. On the post level, we actually have a lot of details available. We know the content size, the job titles, locations, companies, and industries. This is easily available through an export. Again, this is unfortunately not available through the LinkedIn API, but I also just don't want to re-aggregate this data. So therefore, I think it's just the easiest to use the export function and to download this information. Finally, I have also derived an extra signal from all the posts that I made in the past. And this is basically saying how strong a post is so that I know how fast it actually is going to be pushed out. I have made here a combination of how long ago it was that my post was published, combined with the global ranking of the post, and then also combined with the amount of views that the post is getting. So now that we really understand our data points, let's now show how we can actually move these data points to our engine. So we have said that we will use the exported signals from LinkedIn combined with some screenshots. When we export the data, they will come to the downloads folder. When we take screenshots, they will come to the screenshots folder. What we now will build is a watch service in Java that will keep track of these folders and will be notified when a new file has been created. This is similarly like the monitor directories principle that is used in antivirus and backup programs. This watch service will act as a producer for a Kafka queue. A Kafka queue is actually an implementation of the PubSub design pattern. So Kafka is a message broker that will actually accept messages from different types of producers and will keep it as long in memory till all the different consumers are able to consume this data and are able to execute their actions. We have different types of consumers here. The first one is the MongoDB database. MongoDB database is a NoSQL database. What this basically means is that we can store here this information from LinkedIn from the post levels in a JSON file, and in that way easily can afterwards search through this database. A benefit also of MongoDB is that it's easily horizontally scalable. This will be historical data that we will use to start building out our machine learning algorithm. On top of this, we also actually will build out a real-time analytics component that will notify the content marketer of the actions they need to take. For example, it might be that they need to boost a few posts to keep their content funnel health on track, or that they need to start preparing to build out some new content because some important content is currently being pushed out, and in that way we actually might see a reduction in the amount of impressions. Finally, what we also can provide here is the funnel health and actually make a prediction about the amount of impressions that we are expecting to see, for example, by the end of the year. So now we have discussed how we are going to efficiently and securely extract our data. So we have shown that we have seamless data retrieval, and we will use the export function from LinkedIn to access the data that we need. We discussed that the benefit is here that we don't need to do any aggregation ourselves, and it's also actually something where the marketing people are already familiar with from the past. We also will be sure to only access specific data points. For example, if we would be using the API, we still would be able to go more granular, but this also opens the door for privacy headaches in the future, and we just chose actually to go with the aggregated data. We have enhanced security because we will actually be using a format which is similar to what antivirus scanners are using. And finally, we also have a reduced environmental impact because we are only going to do data processing on the client, and we are also not going to do any unneeded calculations. So now that we have gotten our data from Kafka to Mongo, we're now going to explain how we actually can build out a machine learning algorithm that we can use for real-time analytics. So like we mentioned earlier, we are storing all our historical data in MongoDB. This data can next be pulled into Python to do some exploratory data analysis so that we can understand what will be the most efficient algorithm to start predicting the post lifetime. Once we are happy with our algorithm, it means we have done a lot of training and testing cycles and finally reported based on our control group, we can actually deploy this algorithm to production, and then we can actually start making some predictions. So for the algorithm that we're going to deploy to production, we will be building out two versions. One version is a real-time analytics version, which is deployed using Spark. This real-time analytics version will be making a post lifetime prediction of the posts for which we see a risk that they were being pushed out. If we, based on this, can see that these posts are going to be pushed out soon, we can actually provide some recommendations to the content marketer. Like we mentioned earlier, we don't want to do these real-time analytics predictions for all the different types of posts because this would be too expensive. And therefore, for the posts that we determined are not at risk for being pushed out, we will also infer the post lifetime based on the algorithm that we made. Next, we build some pipelines in Python and SQL that will be next extracted to a star schema in the data warehouse. By combining all these data, we can build out an executive report, for example, in Power BI, that in this way we can also show to the executives whether we are on track for meeting our content performance goal or whether we will need to take some extra actions. Now that we have successfully built out the engine, let's now see how we can actually improve this engine even further. So like we mentioned earlier, we have the MongoDB data to build out a machine learning algorithm. What, however, also is important to know is that each day we might have posts that are actually being pushed out of the rankings. And when they're being pushed out of the rankings, this actually means that we have an extra signal about what their effective post lifetime was. When we have this effective post lifetime, we can compare this with the predicted post lifetime. By combining these signals, we can improve the machine learning algorithm and we can actually go to further deployments. When we are analyzing the different types of post lifetimes and the post lifetime predictions, we actually also might see that for certain type of posts, the prediction is lower. This is also a moment to actually start doing some extra categorization of these posts. We can use large language machines here. And when we are able to split out this algorithm in different subcomponents, this is also called dimensionality reduction. Combining the use of the predicted lifetimes with effective lifetimes, and in this way, improving the machine learning algorithm is called active learning. So to conclude, we were able to build out a manageable data process and we were building on successes. So we are continuously computing the funnel health. Based on the post lifetime, we can plan high quality posts. It's also important to note we only focus on the strong posts and in this way also are able to gain human effectiveness. We split up the posts in at-risk post and healthy post so that in this way we can optimize our compute resources and only are using the real-time analytics to perform analytics on the risks post. It's also important to note that we will never be focusing on more than 200 posts at a time. Finally, let's conclude our presentation with our conclusion and call to action. So we went through a realistic system design interview today. Parts of the system designs, we discussed the system design for a modern data app. We used a practical application that combines generative AI and human strengths. We discussed data collection, PubSub design pattern with Kafka, real-time analytics, how you will be using this to develop machine learning algorithms, how this will fit in an executive dashboard, how you use a star schema in your data warehouse, and how we finally can use predictions to build out recommendations. We also made sure to include some aspects of responsible AI. We are sure that we are privacy and security aware and that we have a reduced carbon footprint. Thank you very much for watching my presentation. You can read the whole design about this application on my blog post. Feel free also for the rest to check out more articles on my blog. You can also connect with me on LinkedIn. Thank you very much for watching and have a great day ahead.